Welcome students. So now we are going to solve the second problem. As I told you in the previous class that we will solve two problems with regard to the evaluation of the capital investment proposals. So in the previous class we tried to learn about the simple calculations of the NPV as well as the time varying NPV. And now in this case we will be applying most of the evaluation criteria. So you are given here the information about a company or maybe a proposed organization or maybe an existing firm which is considering two projects. So let's read it carefully and then we will try to answer all the questions asked here. So it's given here that XYZ is considering two projects, M and N, for making investment for manufacturing certain products as required in the market, right? Certain products as required in the market. Each of the projects require 50 millions worth of the investment. Each of the projects require 50 millions worth of the investment. The expected cash flows from these projects are given to us. So outflow is already given to us, that is the 50 millions, it's already given to us. And from the project M, we are given the information only for 4 years, that is 11 million for the first year, 19 million for the second year, 32 million for the third year and 37 million for the fourth year, right? So in this case, we will have to calculate the required criteria. And for project N also, we are given the information about the first year, that is 38 million. The cash inflow is 38 million. Second year, it's 22 million. And third year, it is 18 million. And fourth year, it is 10 million, right? So in this case, we are to answer by using this cash outflow and cash inflow information, we are to answer certain questions. So first question asked here is that what is the payback period for each of the projects? This is the first non-discounted criteria. That's the payback period, and then we will move for calculating the discounted criteria also. But the first and the important estimate we want to make here is that what is the payback period for each of the projects. Now for say doing all this, for knowing the payback period for these projects, if you look at it with the naked eyes, means you look at the cash inflow, so how much we have to recover? We have to recover only 50 million rupees of the investment which we are going to make in the construction period or in the zero period. And that has to be recovered from the cash inflows, and cash inflows are given to here is that is in the annual form or in the annual way. So if you look at this annual cash inflows, it means first year we are recovering 11 millions. This is undiscounted, non-discounted. We can say the absolute value if you take. So first year we are getting 11 millions back and second year we are getting 19 millions back. So this plus this, when you sum it up, this plus this becomes how much? 30 millions. And you have to recover 50, so you need to recover something from this also, that is the 20 millions of the cash inflow has to be recovered from this cash inflow. It means just a rough estimate if you want to make it, you can say that if you want to talk about that the project payback period for project M is lies somewhere between the 2 and 3 years. It's not exactly possible to be calculated in the absolute way that it is 2 years or 3 years. It is something you call it as 2+ years, because after 2 years you will be recovering 30 million rupees, and for the remaining amount of the 20 million rupees you have to recover it from the cash inflow coming in the third year, and that is 32 million. So we don't want 32 million. We don't want the total recovery of 62 million. That is the total recovery or total inflow available from the project, but we are only concerned about the payback. So when this 50 million will be returned back to the entrepreneurs or to the promoters. So roughly you can say it's a period between, just looking at, because it's a very simple problem and very lesser number of the years of the cash inflow information is given to us, only 4 years. So first year, okay, 11, second year 19, so it's 11 plus 19, 30, and you need 20 more, so you will be taking this from the third years of the cash flow of 32 million. So we can say that roughly the time period, the payback period is somewhere between 2 and 3 years. But exactly if you want to calculate, so you can calculate the exact also, and let's calculate the exact payback period for the project first one, that is the project M. So for this purpose, for calculating this project M, the payback period, which is the exact period you want to calculate is, so it's the first question we are going to answer, and this is the payback period for the project M. And for calculating this, you have to use one formula for maybe calculating the exact payback period. So you have to use this formula, and this formula is basically year, or you call it as the year before break even, right, year before break even plus uncovered amount. So, for this is the year before the break even and divided by the uncovered amount. This is the uncovered amount. If you take this is the uncovered amount we have to take in the numerator. So, year before the break even and then uncovered amount and to be divided by the cash flow in the next year. Cash flow coming in the next year. Cash flow coming in the next year. Maybe next year after the maybe this particular period, that is the year before the break even. So, it is the uncovered amount is how much? You have to take the uncovered amount and then in the denominator you have to take the cash flow coming in the or cash inflow coming in the next year. So, for this reason, what is the say year before the break even for this particular part project M? This is 2. And how much is the uncovered amount which you have to recover now? We have already recovered 30 million. So, we want to recover the 20 million and cash flow coming in the next year is that is 32 million. This is going to be 32 million. So, if you divide this 20 by 32, so you will be able to find out some fractions and finally you will be able to say that the payback period, exact payback period for this project M, this is the non-discounted payback period for the project M is basically 2.63 years. 2.63 years is going to be the payback period for this project M, and exactly we can calculate it. So, you have to apply this formula year before the break even. Break even means when the cash outflow is equal to the cash inflow, sum total value of the cash inflow, that is a year, and that we want to calculate the break even means that we want to calculate the payback period. Payback period means when the outflows are equal to the inflow, and in a way we call it as a break even also. So, year before the break even plus uncovered amount. So, how much was the uncovered amount? We had in the first year 11 million, second year we had that amount of say 19 million. So, total we recovered in the first 2 years was 30 million and 20 million we had to recover. So, amount uncovered amount is or unrecovered amount is, you call it as uncovered or unrecovered amount is say 20 and cash flow coming in the next year was 32. So, finally, your payback period for the project M, exact payback period for the project M is going to be 2.63 years. Similarly, you can calculate the payback period for the project N. If you apply the same formula here, so for the project N, the payback period would be something like that 1.55 years. 1.55 years by applying the same formula, that is the year before the break even plus unrecovered amount. But it will be, you call it as the, sometimes we write it as the unrecovered amount or we sometimes we write it as the uncovered amount. So, we will write it, better would be to write it as that is the unrecovered amount. Unrecovered amount. So, this is the numerator and denominator is the cash flow coming in the next year. So, in the first case we have taken 2 years is the year before the break even, unrecovered amount is 20 millions and cash flow coming in the next year is 32 million. So, for the project M, this is the payback period of 2.63 years and applying the same formula to the project N. So, PBP for project N is also when we calculate it, so it is 1.55 years. So, finally, this way we can calculate, means roughly we can calculate, this is the simple or the roughest way or the simplest way of calculating the payback period of the projects, where you are given the information about the cash outflow and cash inflow. No discounting of the cash inflow has to be done at any rate, and finally we have to compare that if the time value of money is not applied at all, then in how many years we are going to recover the investment, that is of the, in this case for example 50 million from the cash inflow coming in the subsequent years. Now, we are going to answer the next question, and in the next question we are asked here, let us go to the problem and then try to see here what is the discounted payback period for each of the projects if the COC is 12%. So, now we will be calculating the discounted payback period for each of the projects. So, we will be calculating the discounted payback period for each of the projects, and for that purpose we will have to make a table, and this is the discounted payback period, and first we are going to calculate it for project M, right. First we are going to calculate it for project M, and for that purpose you have to make a table. That's better if you make a table. So, in the table first we write here year, then we will write here cash flow, right, and then we will write here the discount factor, right. This is discount factor and you are given the discount factor at the rate of 12%, right, and then we will have to calculate the present value, and then we have to calculate the say you have to calculate the net say cumulative net cash flow after discounting. So, we have to find out the cumulative net cash flow after discounting. We have to calculate the cumulative net cash flow after discounting. So, we will have to apply this and try to understand that how we can calculate these values, and for calculating these values we will have to misuse this table. So, in this table we are taking the year first, we are taking the cash flow as it is given to us, the raw cash flow, discount factor we are given 12%, and present value we have to calculate, and then we have to calculate the cumulative net cash flow after the discounting. So, we are given here years, right, 0, 1, 2, and this is 3, this is 3 and this is 4, right. These are the years given to us, and in the 0 period you are given the cash outflow of the 50 millions. This we are taking the amount in millions. We are writing here, this is the amount in million. So, only one time we are writing on the top, this is the cash outflow in the 0 period. In the first year this is going to be 11 millions, then it is going to be 19 million, then it is going to be 32 million, and last is going to be how much? 37 million. And discount factor when we are applying here, so discount factor here we are taking as 1, right. This is the one discount factor we are taking, because 50 million in the current period, so we are discounting it at the same discount factor, and then for the others we have to take the discount factor here. So, for this part the discount factor is 0.893. So, you can simply take it from the present value interest factor table for year 1 and at the rate of 12%, and at 19 if you want to take it, this is 0.797. 0.797 you can take it 0.797, and in this case if you want to take if you want to calculate yourself, you can calculate that way also, but if you want to take it as a ready made, so 0.797 is given to us, and for the next cash flow for the next year, year number 3, it is going to be 0.712, and for the next year it is going to be how much? 0.636. So, these are the discount factors we have taken from the present value interest factor table, and if you want to find out that what is now the present value, so it is going to be present value in this case is going to be again same, that is the 50 million. This is 50 million. So, this is the outflow, we are putting it in the parenthesis, and when you take the other values here, so these are the other value. If you multiplied 11 by 0.893, this comes up at 9.823, 9.823, then we have to take it as 15.143, 15.143, then we have to take it, this is going to be 22.784, and if you want to take this one, so this is going to be, last one is going to be 23.532. These are the total, you call it as the present value, and if you want to calculate the cumulative net cash flow after discounting, so we are going to take it here. So, I am going to put it here, this is 50, right, and you are going to recover it. So, from this 50 for recovering this 50, first inflow is going to be 9.823 when we recover it. So, how much we are left to recover? We are left to recover is 40.177, right, and the next would be, that is minus, means after recovering this, next amount you are recovering is 15.143. So, this will be, after this we are left with missed to recoveries, that is 25.034, and next we want to recover is, that is the Next balance is we want to recover is this is 2.250. This is again minus, and after that the positive balance left with us is that is the 21.282. So it means up till this point we have recovered. We had to recover the 50 million rupees. After recovering in the first year, that is 9.823 millions, we are left to recover the 40.177 million. After recovering 15.143 more, we were left to recover 25.034 million, and in the next third year, when we recovered some more amount, we found it, that is 22.784. So we were left only to recover 2.250, and finally at the end of the year, after recovering this 2.250 from this last discounted balance, so we are left with the positive balance of the 21.282, right. So for calculating the discounted payback period, you have to apply the same formula, and that formula is basically the years before the break-even point, or maybe the years before the break-even of the cash flow, and then the unrecovered amount divided by the cash flow in the next year. That would be the simplest form. And sometimes you cannot make this particular column. You can avoid this column also if you don't want to make it directly from this particular column, that is the discount factor and present value. From this present value as well, you can directly calculate the discounted payback period. So for calculating the discounted payback period for project M, you have to use this formula, and this formula is basically what we are going to say here is that when we are talking about this amount, so up to 3 years it is not recoverable. So the time period is something you call it as 3 plus you want to recover the remaining amount. So it is 3 plus how much you want to recover it? It is 2.250, right, and you divide it by the total amount, you can call it as. If you divide it by the total amount, means the cash flow, discounted cash flow coming in the next year, this is going to be 23.532. So if you solve this, so you will find it that this is going to be 3 plus something, this value is going to be, if you find it up, it's going to be 0.9. So finally we can say cash flow, but the payback period is going to be 3.1 years. But discounted payback period is 3.1 years for the project M. So you have to take this, you have to take the years first, you have to take the cash flow which is given to us, you have to apply the discount factor at the discount rate 12%, calculate the present value, and finally you have to sum it up applying this formula, that is the years before the break even plus unrecovered amount and divided by the cash flow in the next year. So if you apply this formula, so you will find it discounted payback period for project M is, this is going to be 3.1 years. So it's a very simple way of calculating it. And if you apply the same process for the project M, so discounted payback period for project N, if you want to calculate like this, it will be something like that, 1.92 years. This will be something like that, 1.92 years. So there is no problem, it's very simple. So it means 1.92 years of the balance, which the time period you can calculate. So discounted payback period for the project N is 1.92 years. For the project M, it is 3.1 years. So project 2, as per the discounted payback period, project N seems to be a better option, or a better investment avenue, or a better investment option, because the shorter the time period, recovery period or payback period, may be discounted or non-discounted, shorter the period, better it is. So on the basis of the payback period, if you have to take a call, so on the basis of your non-discounted payback period, even in that case also the project N is better, and even if you want to take into account the discounted payback period, still the project N is better, because there the payback period is 1.92 years, close to 2 years, and in the first one, project M, the payback period is almost 3 years. So there is a difference of 1 full year. So our objective should be that the investment made in any venture should be recovered as early as possible. So shorter the time period of the recovery, or the discounted payback period, or maybe non-discounted payback period, it is better for any investment decision. So we should take the investment decision on the basis of the shorter payback period. And in this case, under both the situations, we have found it out that the payback period is the shortest for the, or the shorter for the project N as compared to the first one, that is project M. So we should accept If it is a mutually exclusive, we should accept project N, but if they are independent of each other, then we can make investment in both the projects depending upon the NPV or the IRR we are going to calculate after this discussion, or maybe after these calculations. So now after this, let's see the next question. And the next question in this problem is basically, what is the payback period we have calculated, what is the discounted payback period we have calculated. Now we will be calculating, if the two projects are independent and COC is 12%, which project the firm should invest in, right? So again we are given the payback, this cost of capital is 12%, and on the basis of that we have to evaluate that if these both the projects are independent, which project we should invest in. So let's calculate now the NPV of the project. So what is requirement? Because on what basis we can evaluate? If the two projects are independent, if the two projects are independent and COC is 12%, which project the firm should invest in? So on the basis of the NPV, we will take a call. So we will calculate the NPV for the project M as well as for the project N, and then we will take the call. So first let's take the first project, and this is project M, right? What are the particulars given to us? Cost of capital is how much? COC is 12%. We are given the COC is 12% per annum, right? This is the COC per annum. Cost of capital is 12% per annum. And now we have to calculate the NPV. On the basis of NPV, we are going to take a call. So for calculating the NPV out of this information, we will have to evaluate it, and for that purpose you have to take, say, first your outflow is how much? The outflow is going to be, we'll have to take the outflow, and if we take the outflow, that is going to be 50 lakhs in this case, and this we are going to put it with the minus sign, and after that we have to take the other things. So we have to take the say plus. What is the first inflow? 11 millions, and you have to multiply it by the PVIF, right? We have to take the PVIF, present value interest factor, and that is at what rate? We have to take this PVIF at, or you can put this 11 in 2. So for this you can even remove the brackets. The brackets are not required here. So you can say here that we are going to take the 11 into PVIF, and what is this? 12% and year 1, right? This is going to be the criteria for us. So it is minus 50 plus 11 into PVIF into 12% and year 1, then it is plus. Next cash flow is 19 into PVIF multiplied by 12%, and year 2 we are going to take here is the year 2, and then we have to take here is the next cash flow is what? Next cash flow given to us is 32 multiplied by PVIF, right? That is again 12%, and year is going to be 3. The year is going to be 3 here. So it means this is the year 3. So we'll have to take this 3, and then we have to take the next one, the last figure, and the last figure is given to us is how much for the cash flow? If you look at this is 37. So for this information, we will have to take this 37 into PVIF multiplied by 12%, and it is the year 4, right? It is for the year 4 we have to take it. So if you try to solve this and you take the discount factor from the discount factor table, present value interest factor from the PVIF table, so it is minus 50 plus. So we are going to multiply it, this 11. We are going to multiply this 11 into, first is how much? 0.893. This is going to be 0.893. So we will be taking this. This is the first factor, and then we will be taking the next one. This is going to be how much? 19 into what is the value of the interest factor for 12% and for the period 2. So this is going to be 0.797, right? And we are going to close it. So this is next one, 32, and the PVIF value at 12% and for 3 years is going to be how much? This is going to be 712. This value is going to be multiplied, if you are going to multiply it, so this value is going to be something like that 32 and to be multiplied by the factor is 0.712. 0.712 and last factor we are going to take here is, this is the last cash flow, 37 into the last factor is going to be 0.636. 0.636. So, first factor was 0.893 for the 12% in year 1. Second factor was here, if you take it as 0.797. Next factor is 0.712 and then last factor is going to be 0.636. These factors are available with us, and if you calculate the value, so it is again minus 50 plus the value is going to be how much? For this the value is going to be 9.823, right? Then next value is going to be how much? Next value is going to be 15.143, and then next value is going to be how much? 22.784, and next value is going to be like this 23.532. So, if you take this into account, these are the positive values, you call it as inflows, and the discounted values of the present values of the cash inflow. This is the present value of the cash outflow. So, from the present value of the cash inflow, if you subtract the present value of the summed up cash inflow, present value of the summed up cash inflow, so this is coming up here as, this is 21.282 million. This is 21.282 million. So, it's very simple it is. You have to take the say present value interest factor, and you have to take it for the 12% for first year, then second year, third year, fourth year, and outflow is 50, that is a negative value, we have to take it as because it is flowing out. Inflow are the 4, 11, 19, 32 and 37 millions. After discounting and summing it up and subtracting it from the cash outflow or from this total value, summed up value, if you subtract the cash outflow, so we are left with the value, this is the positive value 21.282 million. And the NPV of the project, if you see, this is the NPV of the project, net present value of the project M. This is a very positive value, better value, and it gives us indication that we can accept the project because NPV is positive. And similarly, by following the same project, you have to calculate the NPV for the project N, and for this purpose, if you apply the same process and you use the same way of calculating this entire thing, so you will find out at that NPV of the project N is 20.644 million. This is 20.644 million. This is the NPV of the project N. This is the NPV of the project M. So, now on the basis of the NPV, we have to take the call, and if the projects are independent of each other, means they are not going to impact the value at all, since they are independent of each other. So, in this case, means there is no shortage of the capital. Capital is not a constant. We can understand that capital is not a constant. So, if the capital is not a constant, you can easily find out that the value is positive in both the cases, and one is going to give you 21 million, second is going to give you 20 millions of the positive NPV, and both are independent. Capital is not a problem. It means we would recommend here that on the basis of this investment evaluation criteria, that is NPV, we can say that the projects can be undertaken, both the projects can be undertaken, and if they are undertaken, they will enhance the overall value of the firm, and final objective of the wealth maximization of the shareholders can be achieved. That's ultimate purpose of any business, that can be achieved also. So, the projects are worthwhile if they are independent and both can be undertaken, and the capital requirement is the important thing. So, if the capital is available, I think the investment is available 50 million for both. If the total 100 million of the capital is available, then I think both the projects can be undertaken, and if they are undertaken, then total positive value of 21 and 20 million they will contribute to the existing value of the firm. So, this is the way we decide simply for calculating the NPV of the projects. Now, let us see what is the next requirement. And the next requirement in this issue was that if the two projects are mutually exclusive means one only can be taken, other can means both cannot be taken when the discount rate is 10 or the discount rate is 15. So, you are given two discount rates here, 10 and 15, and in both the cases the projects are mutually exclusive. So, in this case you have to follow the same process. I will not do it because it is very simple. You do not need to have to worry about anything because the process is simple. Only you have to say change that. You are given the cash inflows, you are given the information of the cash outflow inflow. You have to change the discount factor. In the one case you have to use the discount factor, that is 10%. In the other case I think the discount factor is 15%. So, you only have to change the discount factor 10 to 15, and then finally you have to evaluate it by following the same process. I can help you to have the values here, that for example, if you calculate the NPV of the project M and the project N when they are mutually exclusive at the discount rate of 10 and 15. So, how much is that NPV? I can give you the values. Rest of the things you can do it yourself because the process is very simple. So, NPV of the project M when the discount rate is at the discount rate of at the discount rate of 10%. So, what is NPV of the project M in this case? So, NPV of the project M in this case is something that is 24.996 million. 24.996 million. So, this is the NPV of the project M at the rate of 10% discount rate, and NPV of the project N at the 10% discount rate. Again, we can find out if you calculate and if you want to find it out. So, you will find out that NPV for this project is something like 23 million point 062. 23.062 million. So, this is the second NPV. You can calculate yourself by applying the same process, and the discount rate here is this is the 10%. And for the second discount rate, when NPV of the projects, NPV at the discount rate of 15%, at the discount rate of 15%. So, if you want to calculate the NPV, so NPV of the project M is for the project M, the NPV is I can give you the value here 16.154 million, right? And for project N at the rate of the 15% discount rate, for the project N the NPV is, you call it as 17.256 million, right. So, one is going to give you 16.15, other is going to give you the 17.256, and at the say 10% discount rate, this is 24.996, right. This is 24.996, and for the project N this is going to be 23.062. So, these are the NPVs available. So, on the basis of these NPVs you can say if the discount rate is 10%, project M is better than the project N if they are mutually exclusive, and at the discount rate 15%, project N is better because NPV is more, that is 17.256 million as compared to NPV of the project M, that is 16.154 million. So, as we change the discount rate, the value of the projects also change, the NPV of the projects also change. So, in the one case at 10% discount rate M is better, and at the 15% discount rate N is better. So, this way you can take a decision, you can calculate the NPVs of the projects, and finally you can take a call that if they are independent then both can be taken. There is no problem, both are going to add the positive value, but if they are mutually exclusive, that only one can be taken, not all, means out of the given proposals only one can be accepted. In that case, we will be taking up the project which is giving us a better NPV. So, depending upon the discount rate, in this case we saw that in the one case project M is better, means when it is a 10%, then the M is better, but when the discount rate increases to 15%, then the project N is better because its NPV is better than the project M. Though there is a marginal difference in both the cases, but still the difference is there, almost a difference of 1 million is there. So the difference is there. So depending upon the discount rate and the availability of the capital and acceptability of the projects, we can take the final call and we can see that the projects, whether the one will be taken or all will be taken. So this is the second last question we have answered, and the last question is that is about, what is the last question of that problem, which is quite interesting. I think if the cost of capital is 14%, what is the modified internal rate of return? If the cost of capital is 14%, what is the modified internal rate of return? And for this purpose, for calculating the modified internal rate of return, you have to use the process of the MIRR, modified internal rate of return. And for using the process of modified internal rate of return, we will go ahead and we will try to understand that how we can calculate modified rate of return. So quickly, let's calculate the modified rate of return for the project M, MIRR, right? And this is for the project M we are going to calculate. So as we see that in the modified internal rate of return, you have to calculate the present value of both. Present value of the cost also, means of the outflows also, and present value certainly of the inflows also. So maybe the terminal value we call it as, we do not call it as the inflow. First we compound the inflows and then we calculate the present value of the terminal value, not of the all cash flows. So in this case we see here that for the project M, when you talk about, we have to calculate first of all the terminal value, and because there is only one cash outflow of the 50 million, so that is going to remain the 50 million, it is in the construction period. There is no cash outflow in the subsequent period, so 50 million will remain 50 million. But yes, we have to calculate the terminal value of the cash inflows. So let us calculate the terminal value of cash inflows, and we will, for that purpose, means what is the, say, discount rate given to us, the cost of capital is 14%, right. So at the 14%, we are going to calculate the terminal value of cash inflows, and for this purpose we have to take here, the process here is that first cash flow inflow is how much? First cash inflow is 11 million, so you have to multiply it by 1.14 and you have to compound it. First you have to compound all the cash inflows, so it will be compounded for a period of 3 years. Then you have to take the next cash inflow and then you have to compound it against 1.14 because that is the cost of capital, so power it is 2, and then next is the 32. Next cash flow is 32, so we will be compounding it again 1.14, but the power will be 1 only here. Last cash inflow is the 37, which will not be compounded, 37 is the last cash inflow, 37 million is the last cash inflow which will not be compounded. So if you see here the total compound value, if you want to calculate the total compound value, so you will find out the output of this would be, if you solve this, this will be 16.297 plus this is 24.692 and this is going to be 36.48 and this last one is going to be 37. Last one is going to be 37, right. So this is going to be the final value, 11 multiplied by 1.14 power 3 plus 19 into 1.14 power 2, then it is 32 into 1.14 and last is 37. So these are the compounded values, right. We have to compound these cash flows, so these are the compounded values, and say finally the total terminal value we have to calculate. So we have to sum it up. So terminal value of M is going to be how much? This is going to be 114.469. 114.469 final terminal value, and for calculating the MIRR you have to use one formula, right. We are given one formula. So that formula is basically present value of the cost is equal to terminal value divided by 1 plus MIRR, 1 plus MIRR power n, right? This is the formula, very simple and standard formula we use for calculating the MIRR of any project. And in this case, we are given the present value of the cost. So if you want to put the values here, so if you want to see the present value of the cost is how much, if you calculate the after this cash flow, so we have to take this all these values, we have to put it here. So finally present value of the cost is how much, 50 million is equal to terminal value is how much, this is 114.469 and it is divided by 1 plus MIRR power n, right? And if you finally solve this, so you will get a equation. This equation would be something like that. If we see this, let's solve it here. So if we try to find out here what is the output of this value, so this is going to be 50 into 1 plus MIRR, 1 plus MIRR, 50 into 1 plus MIRR, power n is 4 here. So because the formula is what? The formula given to us is the because we have put the values here, so we will put the value, this power 4 here. So for this purpose, we will have to put the value of this as 4. This 4. So when we multiply this, so it is 50 into 1 plus MIRR power 4. And this is going to be how much? This is going to be equal to 114.469, right? And if you solve this entire thing, so you will find it, you will find this value, that is 50 into 1 plus MIRR power 4 is equal to 114.469. And if you want to solve this, so it will become something like that. If you do this, it will become 1 plus MIRR power 4 is equal to this value. If you calculate, this comes up as 2.289. And MIRR out of this entire calculation, if you want to see here, this is almost, you can say, 23%. This is 23%. If you see this, so MIRR is going to be 23%. So finally, we got this model. The model says that present value of the cost we have to take, and that is equal to the terminal value divided by 1 plus MIRR power n. So when we place the values here, it is 50 is the present value of the cost, because it does not need to be say discounted against any discount rate. It is in the current period, and that is equal to the 114.469 and divided by the 1 plus MIRR. And if you solve this, so finally this becomes 50 into 1 plus MIRR power 4, and that is equal to 114.469. If you finally go ahead with this equation and this process, so this comes up as 1 plus MIRR power 4, that is equal to 2.289. And after solving this and calculating the MIRR, you can say that this is going to be 23%. If you solve this, right, particular equation, if you solve this, so final value will come out as 23% of the MIRR for the project M. This is for the project M. We have calculated this one. And if you follow the same process for calculating the MIRR for the project N, so for the N also the MIRR would be 23.26%. 23.26% it is for the project N. So for the project M it is 23%, and for the project N this is project M 23%, project N is 23.26%. So almost same MIRR, both the modified internal rate of return, both the projects are giving. So depending upon the availability of the capital and the other factors, if the capital is available, capital is not a constraint, projects are independent, both can be undertaken, because MIRR given is 23% in almost in both the cases. And if cost of capital is, as I told you in the previous classes, that in India the used rate of return, that is the required rate of return, is around 15%. So if we also assume that the cost of capital is same in India, that's around 15%, then these two projects are giving us good returns, around 23%. So depending upon the total investment with us, if both the projects can be undertaken, because capital is not a constraint, so we should undertake both the investment options. But if there is some capital shortage and projects are mutually exclusive, then I think as per the MIRR, we would go for 23.26% return, and that is available from the project N. So in that case, the project N can be taken, or both the projects can be taken. So this is the way how we can calculate the different criteria or the values of the different criteria for evaluating the capital budgeting proposals. And as I told you that out of the discounted and non-discounted criteria, we should use at least one non-discounted criteria and one discounted criteria. So out of these two, one each from both discounted and non-discounted if we use and take the decision on the basis of that. So we would be at a better place, better informed, and finally if we undertake the project on the basis of this information, it would be a successful venture. So with this we will stop the discussion on capital budgeting or investment criteria to be used for the evaluation of the projects or the capital budgeting process. And after this, in the next class, we will start talking about the estimation of the project cash flows. Till then, thank you very much.